And now we will pass to our next speaker of today's session. That's going to be Daria Andreevskaya. She will show us. She will show us a tutorial about on how to use our marine products on QGIS. Daria, if you're with us already, yes, perfect.
Yes, I'm here. You hear me?
Yes, loud and clear.
Great.
Whenever you want.
I share the screen, right?
Yes, whenever you want.
So, hello everyone. My name is Daria. As has been said, I work at Novelties, and today I'm here with you for about an hour to show you how to use Copernicus Marine Service products in QGIS software. So, our plan is that we're gonna first start with beginner's tutorial. So it's going to be more detailed step-by-step instructions about how to use products that we can download from the platform, how to ingest them in QGIS, how to work with them, and see what we can do with them. And for the second part is going to be a brief sneak peek of an advanced scenario. So it's going to be a short introduction of more complex exercise. And I'm not gonna do the step-by-step instructions. I'm gonna just show you the results of already existing project in QGIS. And yeah, just tell you some specific features we used. And if you want to have more precise instructions on this advanced scenario, you can go to Padlet. There's gonna be a video about this scenario with full instructions. And also, I believe there's gonna be a PDF version. So let's start. And first we are going for beginners scenario. So in this scenario, we're going to study extreme wave conditions, which occurred in this region, in the Iberia-Biscay-Ireland region, during winter 2013-2014. So these extreme wave conditions were characterized, of course, with significant wave height, which is a variable which is used in oceanography as a variable to measure the heights of waves. So also, yes, what we're going to do is not only study the evolution of this variable, but also how we can use it. For example, here we decided to apply to show you this application as how to build a safe ship route, trying to avoid extreme waves. So what we're going to use in this exact tutorial, we're going to use two model products from Copernicus Marine Service. First is this one, is ocean wave reanalysis, which we will use only significant wave height. And the second one is ocean physics reanalysis, which we're gonna have our current velocity and direction from it. So I think Alexander already explained to you how to download data from a website. You log in, and I think yeah, he mentioned. So here we just go very briefly. You subset your data. You choose whatever variables you want, the place, and of course the date. So I already prepared it, of course. I don't need to do it again. And our products both are in hourly. Yes, hourly. Okay, hourly, daily, monthly. But what we're gonna use it daily mean. So we go into our QGIS software. So you open, you create new project. Here you have just new. And first what we're going to do is we're going to, of course, add some background to have something. So we go to layer, we add layer, oh sorry, create layer, and add. And yes, this one, WMS. And here, I already have map server demo, but if it's a first time you work in QGIS, you might not have it. So you click on new, you put a name, whatever you want. and you put in URL. I don't have it right now, but you will have it in a PDF version. Then you add it, you click OK, and here we have it. So we connect, and we have several of layers which are included. We are most interested in Blue Marble World. We add it and we close. So here we have our background. We zoom in our more or less in the area we're interested in. And just a quick, yep. So what we're going to do next is we're going to map our variables from Copernicus Marine Service products. And for this, we use this plugin, that's CDF to GIS plugin. And this plugin has been developed by Novelties engineers. And this plugin is made just to ease the process of ingesting Copernicus Marine Service products into QGIS, because basically all the products are in a CDF file format, which is very good for handling big data with a lot of variables, like nested variables. And initially in QGIS, there's not very convenient tool to use for importing CDF files. So this tool is much more convenient. And if you want to read more about it, and of course, if you want to have this plugin, which you actually should have to follow this tutorial, you can go to this page on the Copernicus Marine Service site, which has all the information about it, how to download, how to install it in your QGIS, and also even some tutorials. So I already have it. And here you can add your NetCD files by browsing through your directories, or you can open your directory. For example, I have these two products I'm interested in. All the products being downloaded and they've been a bit adjusted. For example, here I think it was just cropped to the dates we need. For example, we're going to look only on winter of 2013-2014, so from 1st of December till 28th of February. So I'm going to just drag and drop them here. Where is it? Oh, yes. So here you can see all the information about what this product contains. For example, the variable, the full name, what's the dimensions and units, and here's some metadata options about. There are a lot of things. If you want to know more about the plugin, you go and go check the website. So first, what we're gonna do, we're gonna work with our. Wait a second. We're going to work with our significant wave height. So first, we're going to map it, and we go to our product, we click, and we add layers. So here you can see that we have layers. Basically, we have data frames, time frames for each day during winter, one time frame per day. So that's a bit too much. So what we're going to do, we're going to choose each 10 days. That will take some time. So you basically hold Control and you choose one by one. Take 20, 30, oh, okay, 31, whatever. 10 and 28. So we chose some. You can change the name. I'm not going to do it. I put add and close. So now I can go back to my project. So here you can see already the evolution of significant wave height. So what we're going to do is we're going to change its properties a bit. Hope you don't see it. Oh, it's here. So what we're going to do is here it's okay. We'll put more neat numbers. It's free, so we put 4, for example, and we invert it like this. And also what we should do is, right now it's continuous, so we'll do equal interval and set only 5 classes like this. And also we don't need this big precision, we can put 1. So you do this, you click apply, okay, and now we see our evolution of a wave here. So of course, more red red color represents more extreme waves than blue. So what we do next, we right click, we do styles, copy style, and we choose all our time frames by holding shift and choosing 2 limit ones, and we paste our style. So now they all have the same style, and here you already can see how our significant wave changes. So here, yeah, you see that it's very, very red, but it's actually, again, a small note. Here we chose that the max value was 4, because it was stated that max value for this exact layer was 3, for example, but it's not the same for this, for example, layer. Let's choose the one that's super, super red. Okay, for example, this one. If we go to properties, we see it's 4, yeah, because we stated it. But if we go to information and scroll down, we see that maximum value is actually 8 here. So each raster layer, these layers are rasters, they have their own main and max, of course. And because we copied style, we assumed that the max is going to be 4 for all of them. So what we can do very briefly is to actually change, so not to have this 2 red picture. We go back to symbology and we put, for example, we saw that it was 8, right? So let's assume it's 8 is a max. We apply. Okay, and we copy our styles again. Oh, nope. Paste style. So yeah, like this, you can see that, for example, the first day is less active right now regarding waves. And yeah, you can see now how it changes. So yeah, it's up to you. You, of course, can put whatever margins you want. It depends on what you want to represent. So this is done. And next, what we want to do is to choose only one specific time frame. So to ease our future work, of course, you can do for several, like you can choose several of them. We're going to choose, for example, this one, 28th of February, because, well, we see that our significant wave height is quite high, maybe actually too high. Let's see. Okay, well, could be this, whatever. So next feature we're going to show is going to be a little like sub exercise. In our sub exercise, as I said before, it's already open. We also imported another product, which is current. So here we will try to work with it a bit before moving to our safe ship route. So here we have our current. You can see that there's northward seawater velocity and eastward seawater velocity. So we basically have 2 components of the same vector. So what we want to do is we want to map these currents into our project, and that's why I said we use only one. We choose only one time frame, so not to import too many things, so not to lose some time. So we decided, for example, yeah, let's choose 10th of February 2014. So I do the same. I choose my variable, I click add layers, and I choose 10 of February. Where is it? 10 of February, exactly. There's also depth, but it's only 1. You can maybe notice that there was no depth on significant wave height because there's no depth there. So we import only this one. We then close, and we do the same with our next component, 10 of July, no, July, February. Okay, add and close. Great. All the layers you added, they're also here, you can see. And this is important because we're going to use it. First, we go back to our project, and you can maybe observe something. It's not very, actually, it's not clear at all what's happening right now there. So we don't really need it. We're gonna untag them, so not to get lost. And we go back to our plugin. So here, we go to the layers tab. And now what we're gonna do is we're gonna see the current direction and velocity by basically combining two vector components we have. So for this, you go to layers, you have your both components, you choose them both by holding Control, right click, and here you have vectorize function. You click on it, and we have a new window. So you choose U and V components, and well, layer U is U, layer V is VS. As we look at the current, we choose current, and downsampling, we choose X5, for example. Downsampling basically means, so now what we're going to do, we're going to see basically arrows that will show us the direction of our flow in the sea. And X5 means that downsampling means that we reduce the amount of arrows like proportional to this number. So for example, if it's X5, it means that 5 less, like your screen will be 5 times less busy. You of course can adjust it. It's just for clear visualization. Output directory. Let me just choose some. And we click on close, vectorize. Yes, we can of course change the name, but yeah, we close, and now you can see these arrows. Basically, they are showing our current. So as we can see here, there is not really specific pattern in how it works, in where it goes, more or less we see, but not much. We see it goes around the bay, for example. So what we're going to do is we're going to adjust a bit our scale. Right click, properties. You go to symbology, and here down you have style, and you can load the style. And for this, you need to go to the directory in which you have this specific style, which is called current scale. I guess it will be provided to you. So yeah, we needed to load it just to adjust our scale, because before it was quite strange, and now it's more neat. We apply, click on OK, and now we see that our color basically changed. It means that here you can see that each arrow with each color, it corresponds to some specific velocity. And as you can see, their velocities are not like huge, let's assume. So like this, you know how to map some vector fields, which could be current, which could be wind, also wave directions could be mapped like this. And now we can move to our next exercise. So we're going to do a ship route, safe ship route. So we assume that we need to go from one port to another port, but somehow we decided to go exactly when it's going to be a storm. Why not? So let's try to build a safe route which will help us avoid this area. So for this, first what we're going to do, we're going to add some specific layer, additional layer, each external. For this, we go to layer, add layer, and we go add vector layer because it's a vector layer. And we're going to browse to the data. So here we have this specific folder with a shapefile of world ports. So ports which are of like mostly major ports of the world. And this information you can also access through the link which is given in a PDF version of tutorial. So here we need only shapefile itself. So the shapefile format. We open, we add, and we close. Here you can see that we now have lots of green dots all over the coasts of the world. So this is a ports, but they're not really representative. So we go again, right click, properties, symbology. And here we can also load the style. And again, in this folder, with the shapefile, there's also a specific style to facilitate work with this exact layer. So here you can see that all the dots are separated by 4 classes. So large, medium, small, and V means very small. So we apply. Okay, what we see now, we see that ports are different points now, different marks, and also have their names. And the names are a bit ugly, to be honest. So I'm going to change it a bit. So if you want to play also with how the style of a layer, here, for example, we have labels. We go to labels and we can change them. I think it is background and probably opacity. If I put opacity like this, oh yeah, great. So no ugly ellipses. And also I'll change color of the text because I think it's not really clear what's happening on the ground when it's on the ground. Okay, why not? Okay, so now we have a lot of ports, but we actually don't need them because we need only in this area. So what we can do now is also apply such a function as filtering. So we have our big layer. WP actually means World Port Index, if someone doesn't know. And what you're going to do is right click on this layer and there's filter. So filter is actually very useful feature you have because like this you can filter by many conditions and really like subset your data to smaller part, which can be useful. So what we're going to do here, we're going to subset it so we only have our ports in this region. So you might choose different different conditions and so on, but we already did this condition. I copy pasted here. So what we want is, as in each port actually has information in country. I don't see, where is it? Okay, where is country? Somewhere. I cannot see it. Okay, country here. Yeah. So what we want to choose, because we're gonna, for example, use only this area, so the Bay of Biscay. For example, here we're gonna choose only Spain and France because that's the regions that are adjoined to these waters. And then also, for example, what I chose, I filtered by longitude, latitude, so to show only relevant ports. So I can put test. So it returned only 42 rows, so it means that all others are out. And I click OK. And now you can see that only these ports on this region are shown and all other just disappeared. But of course, if you click on filter again, here is a little icon, and you remove this condition and click OK again, all the ports that you had, all the previous layer will be returned to you intact. So it's not like it's lost. So okay, now we have it. And what we're going to do is we're going to draw a ship route between 2 ports. Let's choose this one, Ferrol in, I assume it's Spain, maybe it's Portugal actually. No, it's Spain, yeah. So in here, oh, it's very slow. I will, no, okay, I'll leave it. And let's, yeah, choose this one port. And well, let's start. So what we do, we want to create our new layer, which is going to be points layer. So we go to layer, create layer, new shapefile layer. All the vector layers are basically shapefiles. So we choose in geometry type. It's very important. We choose points because we're gonna put points, and then file name. We go. I'll choose ship route. Right. Oops. Okay. Yes. So we save it. Now we have our new layer showed here, but there's no points because we didn't add anything. So we click on it. We click on this editing mode. And now we choose this exact icon, which will allow us to put some points. Now here you see some cursor, which you can put on, choose a point. So first we will put, of course, our port. And here you need to put ID. So just put them one by one. So what we're going to do now, we're going to add some points, trying to follow as close as possible to the shore, because we see that there's less of the wave height is less there, and also can see that the current is, well, here it's quite fast, but here is not. But also, if you want to really make it more advanced, more hard, you can try to also follow the current itself with all the arrows. So what I'm going to do is I'm going to put another point, for example, here, and like this. Yes, it's going to be a bit dark. It'll take some time. I'm not going to be very precise for this because it doesn't make much sense. It will take too much time. So it's 3. Let's assume 4. Somewhere here 5, 6. Where is our port? Okay, this is our port. For example, 7, and let's put our port as 8. Okay, great. So we added some points. They are a bit lost on, I will change the style. And before we move, we should untoggle this one icon, so we save our changes. Great. Let me change the style quickly, maybe to some blue. Is it better? Well, a bit, yeah. But actually, let's change it symbology to something very popping, yeah, like this. Apply. Okay, well, yes, great. Now we really can see it. So now we have our points we chose. Again, it can be completely different from yours. So what we want to do now is we want to add longitude and latitude, so coordinates, to these points, because after we want to create a ship route, so basically the path, we need this information to be written. So what we're going to do, we go to processing toolbox. If you don't have processing toolbox, at some point you go here, processing, here on a layer tab with processing, you click on toolbox and it appears. So we're gonna search for add geometry, and here we have it, and it's usually in vector geometry. So we click on it. Okay, it's here. So ship route, yes. Layer CRS, yes, we want the coordinates, longitude, latitude, and we can create a layer, but I want to do that. Just run. Okay, we see new layer. That's basically the same, you can see now. But if we right click, open at, oh no, I misclicked, sorry. Open attribute table. Now we see that each point has X coordinate and Y coordinate. Great, that's what we needed. Also, what you can do, you can also see what's the significant wave height at these points. For example, if you want to check, but yes, I put them properly. There's no danger, no extreme wave conditions there. To do so, as we have only one raster layer, which we want to extract data from, we go to sample, I believe. Yes, sample raster values in a raster analysis tab. double click, and you can put added geometry info or your ship route, doesn't really matter. And a raster layer, you choose one that's what we have here, what you want to extract the data from. So that was our 10 of February. 10 of February, 10 of February is this one, I believe. Yep. So again, you can save. I'm not going to save it. Run, close. And here, again, same points, nothing changed except for attribute table. Here, you can see the values of significant wave height. According to each point, you can right click flash feature to see. Okay, you see that here it flashed. Let me do it again. Now it's here. So you can locate them. And you can see that, for example, our first point and our third point, no, not third, yeah, only first point doesn't have any data on it because I guess it fell on, yeah, it fell on ground, you see. So there's no raster layer at this point. There's no data, but so here you can see that, for example, on point 8, we are very good with our significant wave height. For example, you know, well, more or less it's not too big, but still, if you be more precise, it's you can adjust it so it's less dangerous route, let's say. So we close it, and what we're going to do now is we're going to have our path finally. So for this, we are going to search for points to path. Points to path, yeah. So I'll put it more precise. So it's points to path here in vector creation. You double click and then you choose one of the layers. So you can see that you can choose only points because, well, it's points to path. What is important here is you should put the layer with geometry info. So with our latitude and longitude, otherwise it's not going to work properly. So we put this. Here we don't really need much. It's some optional stuff. Again, you can save. We can run. Hope it worked. Yes, great. So now we can see a path between these points. So it's been connected. And let's change its style to make it more popping. Okay, let's do, I don't know, make it thicker and okay, I'll put even more. Let's put, I don't know, 1.6, maybe it's too much. Okay, no, it's good. So now we have our path. And what we want to do is, well, we calculated our ship route. And what we want to do is to know the length of the route and maybe, yeah, like more, you can actually have more data, but we will stop only with a length. So first, what you can do is you can have length of the whole route, right? Or also you can have a length between each of the points. We will do both. And for the first, to know the length of a full route is quite easy. We use the function we already used, add geometry attributes. But now we use it for our path. And important here, we use not layer series, but ellipsoidal to have it not in to have it on in real coordinates. So we run, we close, and we have a new line you can see on top. And if we right click and go to open attribute table, you can see some information, and also you can see length of a full route. It's in meters, so you can see it's 1 million and 100,000 whatever. So next. Okay, that was easy, great. But now I want to see each part of our route. What's the length of each part? So for this, it's a bit longer. And for this, we go to first, we have our line, right? And that's the one line. So our the QGIS thinks that is one line and a lot of points. So what we want to do, we want to split lines at points. Yes, as I already used it, it's here, but it's supposed to be in the saga part. It's splint lines at points. We ignore that. So here, what we use is we choose our path because, well, we don't care if it has length. Like, so for example, we don't need our added geometry info layer. So split features are the features we want to use to split our path. And for this, we're going to use ship route. Yes. And separate lines. Yes, good. Run. Okay, it will take some time. Okay, I think it's good now. Yep. Now we have our new line. Again, it's the same line, nothing specific happens. Open attribute table, we can see only the each part of it. But as we split, before we move next, for basically next step is to calculate our lengths. So to do this, we first need to fix geometries, because very often when you use some conversions, for example, from raster layer to vector layer, or the opposite, when you use some splitting, some more advanced tools in QGIS, for example, this Saga is more like advanced, and GRASS also. Your new geometry has some errors. So you won't see it with your own eyes, but when you will proceed with some spatial analysis, it won't just let you proceed, but it will say, I cannot do anything, please fix your geometries first. So what we're gonna do is we're gonna fix geometries by just put fix. Okay, it's here in vector geometry. Double click, we have intersection. Again, you can save it, run, close, fix geometries. The same line, again, as I said, you won't even see what happened, what changed. And the last step is to know the length of each part. And for this, we do the same what we already did. We just go to recently used and we see add geometry attribute. So we already did it, so we do it again. We fix geometries, we put ellipsoidal, run, close. New layer, open it, and now you see your values, distances. Actually, I missed something. Let me really click remove this layer, because when I was adding geometry attributes, I think I forgot to put, no, sorry, it was actually good. Fixed geometries, yeah, it was good. I was just thinking about another tool which actually needs to have more input. Okay, so it's like this. You see the length in meters again between each of them, and you can flash the feature to see. For example, okay, here you can see that the length is somehow 0, which is strange. But if you flash the feature, this feature actually doesn't exist. At least we don't see it. Well, cool. What can I say? Yeah, you see that also a bit, how to say, not in order. So actually, I did notice this happening sometimes. Yeah, if you flash all of them, you see that they all are included. I did notice that sometimes when I do this procedure, it creates a new feature which has like 0 everything, basically 0 length and so on, and it's not even like on the map. I honestly don't know why. Well, it doesn't really, it doesn't really change things for us. We can still see it. We can still see our distances. I'm gonna look closer on that later, but yeah. So that's all for this exercise and for the tutorial, for the beginners one. And so yeah, here we learned how to map products, Copernicus Marine Service products in QGIS by using specific net plugin, which is called net CDF to GIS. And yes, we learned how to visualize our evolution, how to do vector fills, which is quite important at some applications. And using this information, we also now know how to work a bit with geometries, add layers, add point layers, turn them to paths, and also to find some metrics like length, for example. So that was all for this. And I guess it's questions now.
Thank you very much, Daya. It was a really interesting presentation, and indeed we have a few questions.
Okay, I stop.
Yes,
Right.
please.
Okay.
Thank you.
Okay. So the first question, great explanation, I agree. Do you recommend any QGIS course, please? Or do you teach one? Would be amazing to gain more skills in QGIS.
Okay, well, me myself, not really like specific course. Well, first of all, if you go to Copernicus Marine Service YouTube channel, they have videos, recordings of the same basically workshops that's been held before, like last year and before. And there are several videos. I think I remember at least 2 or 3 different topics with 2 or 3 different regions. So there are more information about, like, more examples on how to use QGIS. But also, if you want to do something in QGIS, you basically go to Google, whatever you use, and put like, oh, I want to do this and this in QGIS, and there's going to be plenty of information, plenty of people who did it. So, and also a lot of YouTube videos. So I cannot recommend some specific, but just searching, putting a request on the internet is usually has a lot of answers.
Okay, thank you. Can we merge multiple rasters on QGIS? I want to merge multiple parameters variables in one raster and have the time as the 3D axis of the matrix.
Multiple rasters. Okay, well, I think what I know. No, we usually mean, if you mean that each raster corresponds to each variable, then as I saw, usually variables are imported one by one. So yeah, but I want to well, that's, for example, for this plugin which I showed, that's a good thing to use because it allows you to easily work with this values of raster and the time axis. Because if I remember correctly, before, when we didn't use this plugin, it was a bit more how to say, not really clear, because it shows you only like 2 dimensions, like omitting the third one, for example, if you have depth or something. So if you did not use the plugin yet, you might try to see what's there. Like maybe you actually see that it's more convenient for you, for your purpose, what you want to do. But otherwise, if you already used, then I think I cannot really answer this question.
Okay, thank you. I cannot work with the plugin. I get this error, attribute error, non-type object has no attribute, right?
Okay, so this is probably one of the many errors that happens when you try to use the plugin in a QGIS, because it all depends on the version of your QGIS. With some versions, NetCDF plugin works perfectly and fast and nice, but with some, it's gonna take you a lot of time to configure it. So the last information I had, that the most stable version of QGIS with NetCDF was 3.18, I believe. Me myself, I use think 3.20, yeah, and it was a pain to work with plugin to like manage it. Also, I know that 3.10 is also easy to install. So most likely, if you have this attribute error, so basically the errors you have from like Python code, but all depends on the version of your QGIS.
On that, I just wanted to add that I got an information from the help center, and there will be an article on this topic soon, because I think we had the same question in the last workshop.
Yeah,
in the
or
previous
some other attribute error, but yeah, like close to that.
Yes. Okay. So yeah, soon you will know more information on this.
Okay.
And yeah.
Thank you. Can I export shapefile table data to TXT?
Yes, you can. In when you have your vector layer, you right click, and there's going to be, I think, exactly export data or something, and you can choose how to do it. I actually can look if yeah, you right click, there's export and save features as.
Would you like to share your screen, Daria?
Yeah, maybe if I can.
Sure, go ahead.
So if you see it.
Yes.
Okay, so for example, I have some layer with points, which is shapefile because all vector layers are shapefile, usually. You right click and there's export and save features as, and here you can choose any of formats basically. There is a TXT table, I'm not sure, package. There's a comma separate value, which is basically what you want, and you can later work with that. And yeah, here you can like tune it. You can put geometry like XY, for example, if you know for sure that your X coordinate is X and Y coordinate is Y, it's going to also import additional geometry. And so yeah, you can do that. And you can even like subset your features. For example, if you have a huge amount of features, but you don't want to export them all, you can first go to here, choose your here, if you see this, you select feature by polygon. If you select feature, you select basically one by one, and then you right click and there's save selected features as. So for example, now it's not available because you don't use it. I mean, you don't have it. But as soon as you select some features, you can export only specific features in like different formats and in CSV as well.
Thank you. And I think we have a few more questions.
Can we use this tutorial with ArcMap? I don't think so.
I mean, it's quite specific to QGIS. So
maybe it's something to consider for the next workshops. But I guess the advantage of QGIS is that it's open source, right? It is free. And
yeah,
that's why we use it as well. But yeah, and one last one.
The null value on the attribute table, could it be due to a previous fixed geometry?
Well, it could, possibly. It should not, because that's why it's fixed geometry. It should not have any errors. But the point is, if you do not fix geometry, you can have some, how to say, like extra things. For example, if you want to try, you can try not to fix geometry, or also, for example, not when you have your points layer, do not add latitude and longitude to it, and try to create a path from it, from without coordinates, and see what's going to happen. Most likely it's going to happen that it will create a circle, not a path. So it will like circle it, and then you will try to find, you wouldn't able to split it, if I remember correct. So yeah, it could be fixed geometry. I will try to look at it closer, but yeah.
Yeah, I think that's all for the questions at the moment.
I think so as well. Can move on to the second exercise, maybe, Daria, if you're ready.
Of course. Just a second. Okay, so I hope you see my screen again.
Oh, good. Yeah.
So for this part is going to be a more like advanced scenario. So basically, we're going to study, of course, the same area, but we're going to study a marine heat wave, which is extended period of regional ocean warming. And well, we're going to study one specific period of time. It's the summer of 2022, because as many of you may know, during this summer 2022, Europe has been hit by an extreme heat wave. So the air temperature was like utmost, and of course, such event will bring some impact on the marine environment, of course, on the ocean. So here I wanted to see how this heat wave brought a marine heat wave, and yeah, see how it evaluates and so on. So here you can see some additional information if you want on the slide, but we're going to our project. And for this, as I said, I'm not gonna do like step by step everything in details. I already have my project loaded, as you see, with all the things done. I'm just gonna show you some results. And first, I will tell you what products we used. I don't see because of the Zoom some of the slides, some of the tabs. So for this, we used the temperature, seawater temperature, of course, and also we used wait, what was yes, oxygen, right? Dissolved oxygen in seawater. So for oxygen, I will explain a bit later why we somehow interested in oxygen. We used biogeochemical analysis and forecast. Here, all the links again are available in PDF. And for the seawater temperature, we used global ocean physics analysis and forecast because it just had more more recent dates. But when we were downloading it, we of course did not subset the whole world. We don't need it, so we just choose the EB region. So that's it. And so let's look. So we having two exercises. First, we're gonna work mostly with seawater temperature, and the second is with the oxygen, dissolved oxygen. So in the first exercise, what's been done first is, of course, our temperature was mapped. Here you can see the evolution, and oh, just a second. Oh, yeah, you can see how the ocean gets warmer and warmer with time. We can basically see, for example, well, the sea, Mediterranean Sea, well, it's enclosed sea. It's of course going to be more warm, but here we're more interested in this part because that's our region. And you can see from end of June how it starts to spread, like this heat wave, marine heat wave. It's getting quite red. So of course, after we ingested the data, we adjusted the style a bit so it's more representative. So again, here we just choose only one time frame to use it further, and it was July 20, I think, this one. Yeah. So, yep. What's been done next is, as you can see here, we have a lot of areas which are not exactly EB, for example. Well, Mediterranean Sea, we're not really interested. North Sea, we also, for example, not really interested. So what we want to do is to narrow down our analysis, and also it will be it's a good example to show you how to what you can actually like basically crop your raster layer. For this, we created a new polygon, and the new polygon created the same way as we did with points in a beginner's tutorial. The only thing is you choose another type of vector layers, not point, as polygon. And then we clipped our this layer. So our raster layer for 20th of July, we clipped it according to this zone, and we got this, you see. So to clip it, you go to raster, extraction, clip raster by mask layer. Here you choose your layer, you choose the mask layer, so the basically polygon vector layer, and you have this. So next, what we want to see is we wanted to see the like we want to see evolution of our variable of seawater temperature in some specific points in this region. The point is that, of course, you can do what we did before with beginners tutorial by basically creating a new point layer and choosing any putting points and locations you're interested in. But if you don't have any like particular interest, you can also do the random points, which we wanted to show how to use. And for this, you need to have this region in polygons, like in the one big polygon. And you can say, well, we already have it. Yeah, cool. But the point is that this polygon also intersects with a land. You can clearly see it in here. And we don't want this because if you're gonna use some specific one function, which I'll show you, it will randomly put points in this polygon. So if we choose this polygon, we're gonna have some point on a land which we are not interested in. So what we do is we vectorize our clipped raster layer like this. And again, you can see it again goes to the ground. And to do this, it's raster conversion vector. Yes, polygonize, sorry, here. And after it's been vectorized, what we did, of course, we fixed geometries, as I told you before, and you can see that when you fix geometries, it actually excludes the ground parts. Also, for questions about fixed geometries, if you want to see more, you can check. I think it's valid. I check validity, yes. So check validity is a function in vector geometry tab. You put your polygon, for example, area vectorized. Where is it? Here, area vectorized, and you run, close, and you have, oh my God, it's too many things. Activate. Yeah, here, for example, it's very quick, but yeah, you can see that this dark, what is this, red, whatever color is valid output, and all the orange is invalid output. So if I remove it, like invalid output, we can see that only these polygons, which are highlighted now in red, are actually valid. So it means that all others are not. So like this, if we won't fix our geometries, we will lose a huge amount of data, a huge amount of stuff for future. But also, as I said before, you wouldn't be even able to run some functions, some features, because it will just tell you like, I cannot work with that because it's broken. So just a little introduction to this. I'm gonna remove it. So we fixed it, right? So now we can see it's great. It doesn't touch land, basically. It's not intersects land. So, but here we can see that it's all lot of different polygons, like for example, this is a small polygon, this is a small polygon, and so on. And as we want to put our points in a polygon, we want it to be one, because if we're gonna use this function, which I'll tell you a bit later, it will put points in each polygon. So we're gonna have a complete mess because we have like some polygons are like this, you see. And if we choose, oh, I want 10 points in my polygon, it's gonna put 10 points here. So no, we don't want this. So for this, we do this. We basically dissolve all our polygons in one. And for this, you can just put dissolve, yeah, this function. You just put input layer, you run, close, great. So now what we were doing is putting points, random points. In the vector creation, you have random points inside polygons, I believe. Yep, I think so. Yeah, inside polygons. Yeah. So you put your input layer. You put points count or point density, basically how it depends on the criteria you want to have your points. And you choose the amount. For example, if I chose points count and I choose 15, it means that it will put 15 random points in a polygon. That's all. And like this, that's what I got. You can see there's a points, I think there are 15, maybe 10, I don't remember. And you see they're randomly scattered in a polygon, not on the ground, not on the land, we see it. And of course, it's going to be different for you because it's random points, so I scattered randomly. Next, what's an interesting thing to have, and which basically was the target, we want to know the values of like the temperatures on these points exactly. And previously, like last tutorial for beginners, I showed you how we did it with sample raster values, I believe, and it was you could choose only one raster layer for this point. So if you know exactly which raster layer you're interested in, that's a good stuff. But if, for example, here we have several days, like what we have a whole summer, each 10 days, and we want to have the temperatures of the water during every, like from each raster layer, so for each day, for each point. And for this, we go to, I think it's add raster values. Yes, add raster values to points. It's again in Saga, so you can see it's a bit more like advanced and so on. It's even like blurred, at least for my version of QGIS. So we go here, we put our points, and it was random points, I think. Yep. For example, here, I think it's recommended to choose this one, the third B-spline interpolation. You can read more about different functions. And the most important is grids, because when you click here, you can choose any raster layer you have. Like here, you have all raster layers you have in your project, and you choose the ones you're interested in. So for example, I'm not going to run it, but I chose all the temperatures because that's what we're interested in. And like this, we got this. Exactly same points, nothing changed on the outside, but inside. In attribute table, now you have basically for each point, it has its own number, of course. It has a date, a time frame, and it has a value of a seawater temperature. And yes, they are, of course, ordered by like alphabetic order, not in a order that we assume it for date, you know. But again, you can flash feature to see which one. Okay, so which one, you know what, on 1st of June, it was 13 degrees. Great. And next, a little, how to say, sub exercise we wanted to show is that's not really connected to the temperatures, like to the heat wave, but we decided why not? Because it's advanced scenario, right? So how to calculate distances between the points, as we already worked with points layers. So here, for example, you have a function, you have a layer, sorry, with the distances between each 2 points in the same layer. For example, if I flash them, you see between this and this, it's this amount in meters. Here, a flash feature, here and here, you see? And to do this, you have, I think it's distance matrix, distance matrix. And yeah, here you can choose between which layers, and yeah. But more interesting was also to find the distance between these points, which we chose, to some specific, to like nearest point from our layer. And for this, we reused this ports layer with world ports, as you can see, as we can already explain. And so what we want to see is we want to see the distance between the point, each point of this layer, to the closest port of another layer. So basically find the distance between 2 point layers, but like the closest one. And for this, there exists nearest hub. I don't remember the full name. Okay, distance to nearest hub. Here, you put your both layers between which you want to find distances. And here you put measurement unit. Yes, that's what I was actually trying to do last tutorial, but it didn't work. So yeah, I mean, it wasn't the right tool. So here you can choose which measurement unit you want, for example, kilometers, meters, whatever. And it gives you this as a result. So here you can see the line between the points we chose to the closest port. There is also another function which called basically the same, but just with, instead of line, just points. It has exactly the same result. It just doesn't print you the lines if you don't want them. If you want to check, you can check, and maybe you will find actually that I'm wrong, and there is actually a difference between them more than lines. So that was the first exercise, and for the second exercise is just basically a small, how to say, like exercise to repeat what you already maybe learned in beginners tutorials, or if you didn't do beginner tutorial, you can see it here. So we mapped our oxygen, dissolved oxygen. And why was dissolved oxygen? Because the high water temperatures, high seawater temperature, it leads to deoxygenation, which means that the oxygen level drops. And that's of course not very good. I mean, too high oxygen level is also not very good, but very low is not good for species either. So that's why this value was chosen to show what else you can do in QGIS with these products. So they've been mapped, they've been, of course, tuned. And here you can see that the blue means less oxygen and red means more oxygen. And for example, let us see all of them really quick. So you can see that after 30th of June, also at the end of June, you can see that this area becomes more and more blue, so less and less oxygen. And this is actually quite coherent with what we got, because we saw for water temperature that water temperature was increasing from the end of June. So it's also a nice thing to like see the correlation. And here what we just wanted to do is to basically how to, again, subset some region. We chose one time frame. It was 30 of August. We vectorized it. I already showed you how to do this. Great, right? We fixed the geometries. And yeah, here you can see that fixed geometries are not really corresponding to the full layer. Yes, because I already applied filter. You can see it here. If you click on filter, I put basically, but I want the oxygen concentration be below, for example, 230, and it's in millimole per cubic meter. But again, just because I was like, okay, I want this number, you can put whatever, like, I don't know, let's put 300 and put test. Oh, apparently, basically almost every part, and you can see how many rows. What if I put 150? Maybe it's not even enough. Only 16 rows, you see. I don't even see where is it, but yeah, you can zoom. Okay, so you see, or you can put equal, you put some more conditions, but again, I already showed you the filter option, and it's just to like remind and to make it stuck in your head. So that's all, very, very briefly. And yes, here we just mostly, yeah, we learned how to map again our products, how to filter them, how to vectorize and fix geometries. Apparently it's important. And yeah, and the first exercise was mostly about how to crop area of interest, how to add some random points, how to extract data, and also to manipulate a bit with points layers, like distance between them and so on. So that was quite a brief sneak peek.